Welcome to this channel. In this particular tutorial, we would be designing a 2 sample and hold path circuit. We would be using the LTspice tool in order to simulate this particular circuit. For more such videos, I request you to like, share and subscribe to my channel below. Now let us start the circuit simulation by placing a behavioral sample and hold function block. So place three behavioral sample and hold functional block for this particular circuit simulation as shown in this particular tutorial. So once we place this particular sample and hold block, we have to place the various passive components, and also we have to place the various voltage source, which would be in a form of a clock. Now we have to define the reference value for this particular sample hold block. So double click on this and define the reference equal to 0.5 as the value. So we have to define the reference value for all three sample and hold behavioral functional block as shown in this particular tutorial. Now, once all the reference value has been defined for this sample and hold behavioral block, we have to place an inverter component. So search for inverter and place this particular inverter on the schematic window as shown in this particular tutorial. So once we place the inverter, we require the various voltage source for this particular circuit. So we require a 3 voltage source. So voltage source V1, voltage source V2 and voltage source V3. So place the voltage source accordingly as shown in this particular tutorial. Now right click on the voltage source V1 and define, click on advanced and define this as sine voltage. Define the DC offset as 0.5 volt. Define the amplitude as 0.5 and define the frequency as 3 megahertz and click OK. Now we have to define the third voltage source. So click on advanced and define this as pulse. Define the V initial as 0. Define the V on as 1. Define the T delay as 0. T rise as 0. Define the T fall as 0 and define the T on as 4.9 nano and define the T period as 10 nano and click OK. Now we have to place the wire. So click on wire and connect the negative terminal to the ground and the positive terminal to the input plus, and the clock V3 is connected to the clock of the sample and hold circuit. Now click on ground and place the ground across the uh, input negative and place this particular uh, ground connection to the sample and hold behavioral functional block. Place the ground connection across the voltage source V3 as shown in this particular tutorial. Next, we have to place two resistors. So this particular resistors uh, is used to sum the output of the sample and hold block. So place these resistors accordingly. Now click on wire and connect the output of the sample and hold behavioral block 1 and the sample and hold behavioral block 2 to the respective resistor R1 and R2 as shown in this particular tutorial, and extend the wire across the resistor R1 and R2. Now let us move this block a bit in order to make the circuit connections. So first thing is that we have to connect the voltage source V2 to the clock of the sample and hold behavioral block and extend the negative terminal of the voltage source is connected to the ground. Next, we have to place the ground connection which needs to be connected to the negative input terminal of sample and hold block, and also we have to extend the wire across the positive input of sample and hold block as shown in this particular tutorial. Extend the wire across the output of the third sample and hold block and connect the inverter to the clock of the second sample and hold functional block. Extend the wire across the positive input of the sample and hold block and place the ground across the negative input of sample and hold block. Now click on wire, extend the wire across the inverter A3 as shown in this particular tutorial. Double click on the voltage source V1 and rename this as Vn. Now we have to place a label net. So click on label net and define this as Vn and place this across the wire as shown in this particular tutorial. Rename the V3 as V clock as shown in this particular tutorial, and click on label net and define this as clock and place this particular clock across the extended line of A3 inverter. Now we have to place the label net Vin across the input of the sample and hold block A2 and the sample and hold block A4. Now right click on the voltage source V2 and define this as V clock 1 and click OK, and click on advanced and select the pulse and define the value of this particular V or V clock 1. So define V initial as 0, V on as 1, T delay as 0, T rise as 0, T fall as 0, T on as 2.5 nano and T period as 5 nano as shown in this particular example. Now click on label net and place the V out T across the first sample and hold behavioral functional block output and define this as V out B for the second sample and hold functional block output. Now we have to also place a label net across the output of the sample and hold behavioral functional block number 4. So define this as vout underscore 2fs and place across the output of the third sample and hold functional block, and place the label net across the output of R1 and R2 and define this as vout underscore 2f and place this on the schematic as shown in this particular tutorial. The next step in this particular tutorial is we have to define the spice analysis, and we have to define the spice directive where we have to define the various models. Click on edit and click on spice analysis and define this as a transient analysis. Define the stop time as 500 nano and select the skip initial operating point solution and click OK and place this on the schematic window. Next, click on edit, click on spice derivative and define dot model switch mod SW and place this particular spice directive on the simulation window. Next, once we have defined the spice analysis and the spice directive, define the resistance value for both the resistor R1 and R2 as 1 mega ohm and click OK. Now click on label net and we have to define the clock for the label net as shown in this particular tutorial. Next, let us run or before running this particular tutorial, save this particular circuit. So click on save as and save this particular circuit in a folder called as 2-path sample and hold and save this particular circuit. Now let us run this particular circuit simulation and now place the probe across the Vout T, click add plot plane and place the probe across Vout B. Again click add plot plane and see the output of Vout to F and also the output across Vout underscore to Fs. Thank you for watching this tutorial. I hope this has helped your learning purpose. I request you to like, share and subscribe my channel below.